Okay, the second question is find the Fourier series of f of x is equal to 1 plus 2x by pi 1 minus 2x by pi in this interval minus pi to 0 and 0 to pi. Hence deduce that pi square by 8 is equal to this series. Okay, now it is a split of function and total length of the interval is from minus pi to pi and the length is 2 pi. Minus pi to pi, its length is 2 pi. Right. Now, if this type of question is given, the first step is we need to write a Fourier series of a function in the interval minus pi to pi is given by this equation. F of x is equal to a naught by 2, n is equal to 1 to infinity a n cos n x, and plus n is equal to 1 to infinity b n sin n x. Now, since it is a split of function, we take this term as phi of x, and this term as psi of x. Now, we need to check whether it is the function f of x is even or odd. For that, we take phi of x is equal to this, replace x by minus x, we get 1 minus 2x by pi. This is same as psi of x. So, phi of minus x is equal to psi of x, therefore, it is an even function. So, if it is even function, immediately we write Bn is equal to 0. Okay, for even function Bn is always 0, no need to calculate it. We need to calculate only two coefficients, this a0 and an. So, a0 is given by from the table as we have discussed in the table. The formula is a0 is equal to 1 by 2 by pi 0 to pi f of x dx. Now, 2 by pi 0 to pi f of x, here we have two values, which term we need to consider. Since the limit is 0 to pi, therefore here 0 to pi, whatever the corresponding function is there, that is our f of x. So, we write 1 minus 2x by pi dx is equal to 2 by pi into integration of this is x minus 2 by pi into integration of x is x square by 2 in 0 to pi. So, 2 by pi, now substitute the limits. Okay, here 2 cancels, if you substitute the upper limit pi square. So, pi square by pi cancels. So, 2 by pi is equal to pi minus pi square by 2. So, if you cross multiply, its value will be 0. So, a0 is 0. Next, an 2 by pi 0 to pi f of x cos nx dx. So, f of x in here also f of x is nothing but this term 1 minus 2x by pi, since it is the interval 0 to pi cos nx 2 by pi 0 to pi 1 minus 2x by pi cos nx. Okay, now you have to use Bernoulli's rule of integration by parts. So, first term is 1 minus 2x by pi, integration of cos nx is sin nx by n minus differentiation of this is 0 minus 2 pi by x or minus 2 pi by x into integration of this term is minus cos nx by n square, and the next term will be 0 because differentiation of minus 2 by pi is 0. So, we stop the integration here. Now, substitute the limits. So, if you substitute the limits, look at the sign term present here in this equation. This is the term. For the upper limit, if you substitute the upper limit x is equal to pi, we get sin n pi. We know sin n pi is 0. Therefore, for the upper limit, this entire term will become 0. For the lower limit, it is sin 0. Sin 0 is 0. So, for upper and lower limit, this term will become 0. So, therefore, we write 0 minus here minus into minus plus minus. So, minus 2 by pi cos n x. So, this is the remaining term we get, right? 2 by pi cos nx by n square. Now, substitute the limit. For the upper limit pi, what it becomes? It becomes cos n pi by n square, cos n pi by n square minus into minus plus 2 by pi cos 0 by n square. Cos n pi is, this is cos n pi and 1. Okay. So, for the upper limit it is minus, so that minus n is here, and for the lower limit this will become plus, minus into minus. So, this is 1. So, this is the value of an. Next, so an is this, therefore, the Fourier series is given by, since a0 a naught is 0 and bn is 0. Now we write only substitute an value here. So 1 minus f of x is 1 minus 2x by pi is equal to this. Now we can simplify further. The value of this 1 minus minus 1 power n is 2. Okay, see, look at here, n is equal to 1 means what? 1 minus minus 1 power 1. So it will become plus 1 plus 1 is 2. So for n is equal to 1 it is 2. For n is equal to 2 minus 1 square will be plus 1, 1 minus 1 is 0. Then n is equal to 3, the value of this is plus 1. For n is equal to 4, it will be 0. Like that, only for odd numbers we get 2 in 2 here, and for even numbers this will become 0. Therefore, instead of 1, 2, 3, we have taken 1, 3, 5, 7 and so on. For those numbers, we get it is 2 by n square cos nx. Okay, so why we have to write in this way? Because we need to deduce the given equation. What is the given equation? You can see the question here. 1 by 1 square, 1 by 3 square, 1 by 5 square. So in order to prove that, we write like this. So now, if I want to write, since I need the series 1 by 1 square, 1 by 3 square and all, therefore this term should be 1. I have to make it as 1. For what value of x, this will become 1, x equal to 0. Put x equal to 0 so that this will become 1 LHS. Take 2 outside, 8 by pi square, 1 by 1 square, 3 square. This is the answer. Okay, now look at the third question. Find the Fourier series of f of x is equal to minus k in this interval and plus k in this interval. So again we have to check whether it is even or odd function. Let us take this as phi of x and this as psi of x. Okay, now phi of x is equal to minus k. Now replace x by minus x. Okay, since x is not there in the RHS, the function will be same. Okay, phi of minus x. Phi of minus x, phi of x is equal to k, and phi of minus x is also equal to minus k. This minus k can be written as minus of psi of x, isn't it? If I take this as phi of x, this will be psi of x. Phi of minus x is also minus k only. Minus k can be written as minus into psi of x. Therefore, it is a odd function. So, if it is odd function means we need to find out a naught and we need to find out only bn. B a naught and an will be 0. Bn formula is 2 by pi 0 to pi k sin nx dx. Okay, in the interval 0 to pi, we have the function k here. So, 2k by pi minus cos nx by n, 0 to pi minus 2k by pi n cos n pi. If you substitute the limit, we get cos n pi minus 1. So we know cos n pi is minus 1 power n. Since minus n is there, take minus n common so that it will become plus 1 minus minus 1 power n. Okay, so therefore the Fourier is given by only this equation, because a naught term is 0 and bn term is an is 0, only we get bn. Next question is, obtain the Fourier series representation of f of x is equal to x minus x square in the interval minus 1 to 1. Okay, now minus 1 to 1, it is an arbitrary interval. We need to compare this with L to L, minus L to L. Okay, minus L to L is equal to minus 1 to 1. So the value of L is 1. Now how to check whether it is even or odd? So we have to replace x by minus x. This is f of x. Replace x by minus x. We get minus x minus of minus x whole square. We get minus x square. So this is not equal to f of x, isn't it? Again, if you take minus n common, we get x plus x square. That is also not equal to minus into f of x. That means what? This is neither even nor odd. Okay. See, if f of minus x is equal to f of x, then it is even. If f of minus x is equal to minus into f of x, then it is odd. Here both the cases are not possible. We cannot express this in terms of f of x plus or minus. Therefore, this is neither even nor odd function. Now, if it is neither even nor odd, we need to find out all the three coefficients a0, an and bn. For a0, you know the formula. If it is arbitrary function, 1 by then the formula is 1 by L minus L to L f of x dx. Since L is 1 here, substitute L is equal to 1 and f of x is x minus x square. Okay. Now integrate this. Integration of x is x square by 2 minus x cube by 3 minus 1 to 1. For the upper limit we get this. For the lower limit minus lower limit is this. Then if you evaluate we get minus 2 by 3. So a0 is minus 2 by 3. Then an is 1 by L minus L to L f of x cos n pi by L into x dx. Okay, so should remember, if it is arbitrary interval, this is not only cos n pi x, cos n pi by L into x. Now substitute the value of L minus 1 to 1, we get this cos n pi by 1 into x. Now we have to use Bernoulli's rule of integration by parts. So we get first term into integration of cos n pi x is sin n pi x by n pi minus 1 minus 2x into minus cos n pi x by n square pi square plus differentiation of 1 minus 2x is minus 2. Then integration of this term is minus sin n pi x by n cube pi cube. So an is equal to, now look at the sine terms present here. This is the sine term and the limit is plus 1. For the upper limit sin n pi is 0. For the lower limit minus 1 is there. If you put x equal to minus 1, sin of minus theta we get, this will be minus sin theta, even though we get sin n pi, so it is 0. For both upper and lower limit, the value of this term is 0. Even sin, for the upper limit sin n pi is 0. For the lower limit, sin of minus theta will get, sin of minus theta is minus sin theta, again sin n pi, so that it will be 0. We left with only this term. Therefore, we write only this term here minus 1 to 1. Okay, so that you can write like this. This term is 0 and this term also equal to 0. So we left with only this. So 1 by n square pi square. So if for the upper limit 1 minus 2 into cos n pi, lower limit 1 plus 2 into cos n pi. So cos n pi, if you take common, it is cos n pi value is minus 1 power n square pi square, and this term is minus 4, we get this minus 1 power n, 1 more minus n, so minus 1 power n plus 1. This is value of an. Now bn is 1 by L minus L to L f of x sin n pi by L into x dx. So this is, since L is 1, we get minus 1 to 1 x minus x square sin n pi x dx. Okay, therefore bn is 1 by L. Okay, if you substitute this, we get this. Now use Bernoulli's rule of integration by parts. So first term into integration of second term, sin n pi x is minus cos n pi x by L minus differentiation of this 1 minus 2x. Again integrate this term, we get minus sin n pi x by n square pi square plus differentiation of this term minus 2 into integration of this cos n pi x by n cube pi cube. So we end the process of integration here, minus 1 to 1. For look at the sine term, for x is equal to 1, sin n pi, it is 0. For x equal to minus 1 also we get sin n pi, that is 0. For this substitute the limits. If you substitute the limit, if x is equal to 1 here, 1 minus 1 is 0. Even for x is equal to minus 1, we get minus 1 and minus 1, right? Minus 1, so it is minus 2. For the lower limit, 0 minus, this is minus 2, and this minus sign we have taken already in the outside of the integral, outside of this bracket. So cos n pi we write as it is, divided by n pi, this n pi is outside, minus this term, minus 2 by n cube pi cube. For the upper limit cos n pi, for the lower limit cos of minus n pi. Cos of minus n pi is cos n pi. So we get this cos n pi is 0. So we get here minus into minus plus, this is minus. So we get 2 by n pi into cos n pi is minus 1 power n. Because of this minus sign, we get minus 1 power n plus 1. Right. Therefore, the Fourier series of this function is given by f of x is equal to, this is the value of a naught plus, this is an, 4 by n square is taken outside, an into cos nx, n pi x by l, l is 1, n is equal to 1 to infinity. This is the value of bn into sin n pi x by l, l is 1, so sin n pi x. Okay, so this is how we do.